Welcome to all. In this lecture, we are going to discuss about Zener breakdown and Avalanche breakdown mechanism. This breakdown occurs in reverse biased PN junction. What is reverse biased? Reverse biased means that is PN junction. How PN junction is formed? P-type semiconductor and N-type semiconductor both are joined together and PN junction is formed. If the P-type semiconductor is connected with negative terminal of battery and N-type semiconductor is connected with positive terminal of the battery, that connection is called reverse biased. Okay, how this breakdown mechanism happens? When the reverse bias applied to PN junction is increased, a point will reach when the junction breaks down and reverse current increases sharply. The specific value of reverse bias voltage is called breakdown voltage. After breakdown, even for a very small applied in voltage, there is more increase in a reverse current. This breakdown voltage depends upon width of depletion region. This width of depletion region depends upon the doping level. The following two processes cause junction breakdown due to increase in reverse bias voltage. One is Zener breakdown, second one is Avalanche breakdown. This schematic diagram shows Zener diode. This is P anode, this is cathode. Zener breakdown observed in Zener diodes. The applied voltage is around 5 to 8 volts. When the reverse voltage is applied to Zener diode, it causes very intense electric field across depletion region or at the junction. Such intense electric field is strong enough to pull some of valence electron into conduction band by breaking their covalent bonds. These electrons become free electrons which are available for conduction. Large number of such free electrons will constitute large reverse current through the Zener diode. This breakdown is called Zener effect. So what is happening in Zener breakdown? So Zener breakdown occurred in Zener diode that applied reverse bias voltage is in the range of 5 to 8 volt. So it causes how this breakdown happens. So when the applied voltage is in between 5 to 8, so it gives intense electric field across junction or depletion region. So this electric field pulls some valence electron from valence band to conduction band by breaking their covalent bond. As a result, free electrons generated, enormous free electrons are generated, and large number of due to the large number of free electrons, large reverse current also flow through Zener diode. So this breakdown is called Zener breakdown. This is the characteristics of Zener breakdown. This is a voltage, this one is current. When the reverse voltage increase and it reach Zener breakdown voltage, there is an enormous or sharp increase in reverse current. So this is Zener breakdown mechanism. A current limiting resistance should be connected in series with Zener diode. In circuit connection, current limiting resistance also connected in series with Zener diode to protect it against the damage due to excessive heating. In Zener breakdown, the breakdown voltage depends on temperature of PN junction. The breakdown voltage decreases with increase in junction temperature. So mainly this breakdown voltage depends upon junction temperature. Second one, avalanche breakdown. Avalanche breakdown occurs in Zener diode. Here the applied voltage is greater than 8 volt. Here what is happening? The reverse biased condition, conduction takes place due to minority carriers. We know that in the when you apply reverse bias to PN junction, across the junction minority carriers only flows. Okay. As we increase the reverse bias voltage to Zener diode, these minority carriers tend to accelerate it. Therefore, kinetic energy associated with this also increases. While traveling, these accelerated carriers will collide with the stationary atom at the junction, and it transfer kinetic energy, and it transfer kinetic energy to the valence electron in the atoms. Okay. Now, this valence electron gains energy, and this valence electron gains energy, and it break from covalent bond, and it jumps to conduction band. Now it acts as free electron. Now this newly generated free electron also will do the same thing. That is, newly generated free electron again accelerated, and this will knock out some more valence electron by means of collision. And again it produces free electron. This phenomenon continues like chain reaction. So this phenomenon is called carrier multiplication. This is the characteristics of avalanche breakdown. Here, when the reverse voltage increases or at around 8 or greater than 8 volt applied, so this gives breakdown. Reverse current increases. So what are the general difference between Zener breakdown and avalanche breakdown? So the first point is, it is observed in Zener diode. Applied voltage, reverse bias voltage is in the range 5 to 8 volt. Avalanche breakdown occurs greater than 8 volt. In the case of Zener breakdown, valence electron are pulled into conduction band due to very intense electric field cross across the width of the depletion region. Avalanche breakdown. Here the valence electron are pushed into conduction band due to energy imported by colliding accelerated minority carriers. Here the third point is voltage current characteristics with the Zener. The breakdown is very short. Here the voltage current characteristics with the avalanche breakdown increases gradually. It's not as short compared to this Zener breakdown. Here the fourth point is the breakdown voltage decreases with increase in temperature in the case of Zener breakdown. In the case of avalanche breakdown, the breakdown voltage increase with increase in temperature. So these are all common difference between Zener breakdown and avalanche breakdown.